Welcome. It is I, Mr. Lewis, your teacher here for your 5.2 section review looking at fossils. Ah, ah. On board your screen right there, you go ahead and see your bell ringer. You know what to do with your bell ringer. Answer it there on that edmodo.com, that good stuff there. We talk about it too, maybe. Alrighty, here is our objectives for today. Our objectives, we have 4 of them. The first one is to describe 5 ways in which different types of fossils form. Then we're going to list 3 types of fossils that are not part of organisms. Then we're going to explain how fossils can be used to determine the history of changes in environments and organisms. And we'll explain how index fossils can be used to date rock layers. I'd like to see an index fossil date a rock layer, wouldn't you? That'd be pretty cool, wouldn't you? All right, here we go. Fossilized organisms. This is where we're going to start off. Ladies and gentlemen, you should know that remains or physical evidence of an organism preserved by the geologic processes is known as a fossil. So anything that is inside, let me just shake my finger at you, sorry. So anything that you find inside of geologic processes is a fossil of a once living organism. Now, typically when we think of these, we think of fossils are found in rocks, all right? And that's because when we think about it, that organism is living, all of a sudden it dies, all right, it's dead. And as it lies there dead, sand and other sediment, fills on top of it, goes on top of it layer after layer after layer after layer, and it keeps squishing and squishing and squishing and squishing and squishing. And guess what? That organism then becomes part of the rock. The part that's left is typically the only part that we have preserved typically in rocks are the hard parts, okay? We don't really have the heart beating around. We don't have the heart preserved. We don't have the skin preserved. We don't have those different things preserved typically. We typically only have the hard parts, which is their bones, all right? We typically only have the hard parts of those organisms preserved in the sediment, all right? Typically, that's what we have. Now, when we talk about fossils, there are several different types of fossils. Now, what you see on your screen right here is called fossils that are in amber. Now, when we talk about amber, amber is a precious stone. Yes, it is. But how did amber form? Well, what amber really is tree sap. Okay, so when you go out there and you cut down a limb or a branch off of a tree, and you see the little sap running, especially on them pine trees, you do that too. Those coniferous trees, you can see that. All right, that sap eventually hardens, and anything that was stuck in that sap, when that eventually hardens, it turns into a fossil, turns into amber. And so when we look at amber, amber is really hardened tree sap is all it is. And if you look down here, you start looking over here at different places, you can see over here, that's a spider inside of that amber right there. There's a frog inside of that amber. There's another insect inside of that amber. There's a lizard, lizard inside of that amber and stuff. Those are all preserved animals inside of that hardened tree sap. Those little organisms, sorry for them, got stuck in the tree sap as it was going down. Now, we also have what's known as petrifaction. This is another way that fossils are formed. All right? Petrifaction is a process in which minerals replace organisms' tissue. And so you have several different types of that. You have permineralization, which they replace. The 2 types are permineralization and replacement, and those are forms of petrifaction. So when we look at these, we see the different types of fossils right here, permineralization and petrifaction. Okay, when we talk about permineralization, that is a pore space in the organism's hard tissue, like bone or wood, is filled with mineral. In other words, all of our bones have pore spaces, have little tiny holes and stuff in them. Those little tiny holes are filled with some type of mineral, all right, like made a rock type mineral. And then when that hardens and stuff, it ends up taking the shape of that organism that was there. In replacement, the minerals completely replace the tissue of the organs, all right? So this here would be replacement. This here is permineralization. Basically what you're seeing here is that those minerals actually replace the fish. And in permineralization, the mineral actually is just filling in all of the space that's inside of that organism. All right. Obviously right there, petrified wood is basically permineralization, is what petrified wood is. Now, we also have animals that have been caught in asphalt. All right. Now, when I was a kid, we called those tar pits, but today they call it asphalt. One of the great examples of that is the La Brea tar pits over in Los Angeles, and they found organisms there from 38,000 years old and stuff. And basically, they could be full organism. Like this is a full organism right here that they found inside of. It was walking along, and it fell into one of these tar pits. And when it fell into one of these tar pits, guess what? It's preserved. It sinks down to the bottom, and it's preserved. So these are different organisms right here that you can see that were pulled out of La Brea tar pits there in Los Angeles, California. And some of these are 38,000 years old. It's pretty amazing. They actually pulled out whole organisms when they pulled them out of the tar pits. Okay. Another way that we have fossils is frozen fossils. Now, when we talk about frozen fossils, what we're talking about is things that are walking around in the Arctic environments, and they actually die in those Arctic environments. And when they die, they get frozen. Instead of sediment being piled on top of them, it's snow and ice being piled on top of them, and it freezes them. The good thing with this is typically we can see what that organism looked like. Right here is a baby woolly mammoth that we discovered that was frozen. Right here is a fish that was frozen as a frozen fossil. And if you look closely inside that picture right there, you can see right over here, that is a woolly mammoth right here in this chunk of ice. Okay. These fossils here that are frozen in the ice, these things have died and have been there for a long period of time because ice keeps piling on top and piling on top and piling on top. Snow and ice pile on top of them, and it keeps them pretty much perfectly preserved when they're frozen like that. Now, there's other types of fossils as well. We have what's called trace fossils, and trace fossils typically are those that show movement. So we can see right over here the footprints. Over here we can see movement, so you see here how the organisms actually moved and slithered around and stuff. So we can see that kind of stuff as well. We can see how fast organisms move based on those lines and the size of their footprints and stuff. And there's other types of fossils as well. And if you're looking at this going, what is this right here? You probably get an idea what that is. That is called a coprolite. And basically what a coprolite is frozen animal dung poop. Okay? And what they are not frozen, but fossilized animal dung. So basically what they do is they would actually look at this. They'd find these little things laying around and in the rocks and stuff, and they would actually cut them open and they look inside of them to see what these animals used to eat. So that's another way we could determine how these animals lived and how they survived for such long periods of time. Okay? Now, another types of fossils are called molds and casts. We have those two types, molds and casts. All right. So a mold is basically this right here, where the organism was there, the imprint of that organism's in the ground, and so you can actually see the imprint of the organism. A cast would actually be where the organism was, and you can actually fill a cast. You can fill this mold to get this cast as well. Okay. Now, let's talk about looking at the fossil record. Now, when we look at the fossil record, the information that gives us tells us is actually very incomplete. It's very sketchy, all right, because the only organisms that survive, or the only organisms that were fossilized, is because are those fossils that had hard body parts. Those fossils that did not, or those organisms that did not have hard body parts, guess what? Typically, we don't find those in the fossil record simply because they don't make good fossils. Because as that stuff falls on top of them, as the sediment goes on top of them, guess what? It starts decaying, and as it decays, it's gone before it is able to be turned into a fossil. So that is one reason. Another reason is because we still believe there's many fossils that have yet to be discovered that we haven't discovered yet. Now, I already said there about soft body parts and stuff. So those are things. And plus, there's areas that favor fossilization and other areas that don't favor fossilization. All right. Interestingly, we look at our fossils. We can also help determine what environments look like. In Canada, they were looking on top of some of the mountains in Canada, and they discovered that there were some marine fossils on top of the mountains. Well, when you see marine fossils on top of a mountain, that can only lead to one conclusion, that marine fossils walked. No, that mountaintop at one time was underwater, and those marine fossils were able to float around on top of those mountains because it was underwater. All right, so that's another way that we can use fossils to help us determine the past. Looking at coprolite and other things, we can determine what the climates were like, what those animals ate, and those types of things. We can determine those different things looking at these fossils. Now, scientists study the relationship between fossils to interpret how life has changed over time. Because obviously, if there's a lot of marine fossils and very few land fossils, that tells us that that time period there had to have been a lot of marine life and not a lot of land life. All right, and so when we look at those different things, we can determine what the Earth looked like and what the organisms were like and what life was like back at the time when those organisms were around. All right. Now, also, we use those fossils to help us date rocks, okay? And when we use those fossils to help us date rocks, here's what we do. We find fossils in certain rock layers all over the world. If we find the same fossil in the same rock layer all over the world, that tells us that, hey, guess what? That rock layer is the same rock layer consistently throughout the world. And then we're able to find, since we're able to find those organisms that lived in a relatively short period of time, all right, in a very limited number of layers, we can help determine, the age of those fossils or the age of those rock layers based off of those fossils, all right? Because if they're all in the same area, so those fossils are called index fossils. They live in a well-defined geologic time period. It's very short, relatively, so short could be a million years, but we talk about billions of years. A million years is kind of short. So we talk about that. Index fossils help us determine the age of rocks, but that index fossil has to be found in the same rock layer all across the world. If it is, that helps us determine. And so there are several examples. Right here you have the ammonite of the genus Tropites, our index fossils. So in this rock layer here, you see the ammonites in it all around the world. If you see these ammonites in that rock layer, guess what? You are looking at an index fossil. All right. There are other things out there. There are tropites that lived 230 million and 208 million years ago. Fossils of the ammonites are index fossils for the same time, for that time period. All right. Those are all index fossils. Another example of an index fossil is a trilobite, and I have one right here. Okay, this is a trilobite fossil right here. Is it real? I don't really know. Ask me in class and I'll tell you the story behind it. But this is a trilobite. If you look on your picture on the screen, you look at this right here. Whoa, you can tell that this is a trilobite. This here is the head, and then this is the body and stuff on the side of it and stuff like that. So this is a trilobite, and this is the closest living thing to this is like a horseshoe crab. But those are examples of index fossils because they're found in a certain rock layer throughout the Earth. Okay, those fake hops lived about 400 million years ago. When scientists found the fossils, they find them anywhere. They assume in those rock layers that they find them, those rock layers are 400 million years old because that's when these things lived, 400 million years ago. Okay, that's pretty cool. I'm holding 400 million years of history in my hand. It's pretty interesting. All right, so index fossils help us to determine the age of rock layers because those index fossils lived in a relatively defined short period of time in history. Guess what? It's your review time. This is your 5.2 section review. It's review time, review time. It's time for the review. Go ahead and I'll shut up and let you listen to this. Ooh, I'm sorry. I'll be quiet and let you read this and take your notes. All right, there you go. I hope you guys enjoyed your 5.2 section video as much as I enjoyed making them for you. You guys all have a great day, and we'll be seeing you in the future.